Alright, so we're going to continue on with 2.1 here. We're going to talk about how to determine z-scores and moving forward with that, okay? So now let's look at this. We got some test results here for chapter 1. We got 20 of them here. So we're going to look at this. And we got a dot plot with all the data and an actual summary statistics. So let's look at this. Gray scored a 65. What is Gray's percentile? So if we've got two of them at 65, we can't count those guys, but we can count this one right here. So we got one set up with that. So we are going to play down with 1 out of 20. Okay, and that's going to give us 0.05 or 5%. So since that's 5%, well, that's not really just 5%. We're saying that Gray is in the 5th percentile, right? So the 5th percentile. Okay. Was Gray above or below the mean? By how many points? By how many standard deviations? Well, 65 and the mean is sitting right at 80 according to the mean scale right here. So we're going to say that he is 15 points below the mean. Okay, so how many standard deviations? Well, if our standard deviation value is 10, so we can simply take our 15 points below, right, and divide by 10, which would give us 1.5 standard deviations below the mean. Alright. So now we got Sam scored an 88. What is Sam's percentile? Well, if Sam scored an 88, it's the only one right there. And we can simply see that we have, out of 20, there's 1, 2, 3, 4, 5 that are above that. So there's 15 below. So on this, we would simply say 15 out of 20, which will give us 0.75. So therefore, Sam is in the 75th percentile. Okay. Was Sam above or below the mean? By how many points? By how many standard deviations? Well, Sam scored an 88. So therefore, Sam is 8 points above the mean. Okay, and how many standard deviations? Well, 8 divided by 10, so it was 0.8 standard deviations above the mean. So that makes sense a little bit now. We're talking about percentiles, right? So let's go in this with a z-score. So z-score is defined as the number of standard deviations above or below the mean. So for your z-score, the formula for that is by saying your value minus your mean all divided by your standard deviation. And you will primarily see this in, say, your x value minus your x bar for your mean, all divided by standard deviation of S sub x. S sub x is the icon you will see in your calculators if you're able to get a TI Inspire, but more likely that is how it's going to be notated for your standard deviation. So Maddie scored a 98 on a Chapter 1 test. Find and interpret the z-score. So our z-score is our value of 98 that Maddie scored minus the mean of 80 divided by our standard deviation of 10. Because it was our standard deviation of 10. If we look up here above, remember our standard deviation was 10. So I'm just going off the data that was already given to us. And so with that, that simply gives us 18 divided by 10. We'll skip a step, make sure I get it all right. So 1.8 standard deviations. All right, above the mean. Okay. And you would write that out by saying, to give a full answer, say Maddie's Chapter 1 test score is 1.8 standard deviations above the mean. And that explains how many standard deviations away that score of 98 was away from the mean. So now we're going to do some little operations here with this. So first, we're going to take each score and we're going to subtract the mean. So the mean is 80. So we're going to do this and fill this in real quick. So it's pretty simple to go off of. We're not doing anything crazy, just subtracting here. So we're going to say 80 minus, or I'm sorry, 61 minus 80. So we have negative 19. Well, if I can write 19 instead of 9. We have negative 15, negative 15, negative 7, negative 5, negative 3, negative 2, negative 2, negative 1, 0, 0, 0, 0, 1, 1. I have 8 above, I have 9 above, 13, 18, and 19. So on the dot plot, just dealing with the scores, we got 61. I use a different color. So we got 61. And we got 65. 2 to 65. And we got 73. And we got 75. Got a 77. Oh, I can roll a 77. Not bad. There's 75 right here. There's 77. We got 78. 2 of them is 78. I got a 79. I got 4 of them at 80. 2 of them at 81. I got an 88. 89. 93, 98, and 99. So let's see what happened when we subtracted the mean from those scores, if anything changed. So we have negative 19, then we got negative 15, 15, we got negative 7, 6, 7, we got negative 5, we got negative 3, negative 2, negative 2, 1, 4 at 0, 2 at 1, we got a dot at 8, 9, we got 13, 18, 19. So the exact same dot plots. Can't go wrong with that. So if we subtract, it didn't really change much, right? So if we're going to look at this here, we simply say the shape stay the same. The center did what? Shifted down by 80. Right? We went from our mean of 80 to a mean of 0. Or not a mean, I'm sorry, a center. I'll rephrase that. We went from a center of 80, because our peak was at 80, to a center of 0. Our variability, well, that was the same as well. We can look at that, because if you're to take 99 minus 61, that should give us 38. And if we're to take 19 minus a negative 19, that gives us 38. So those guys check off. Okay, so let's see what else we can do and if anything else changes. So if we're to simply take this and we divide by the standard deviation. Standard deviation is 10, so we're taking those values we just got from subtracting the score minus mean and dividing by 10. So we're putting in the decimal here. So negative 1.9, negative 1.5, negative 1.5, negative 0.7, negative 0.5, negative 0.3, negative 0.2, 0.2, negative 0.1, 0, 0, 0, 0, we're going to say 0.1, 0.1, 0.8, 9, 1.3, 1.8, 1.9. So now we're going to dot plot this and see if anything changed. So if we take these values that we just calculated right here, and we put a dot plot for it. So we're going to take negative 1.9, negative 1.5, got two of those, got 0.7, so 2 versus 7, got 5, got 3, we got a couple at the negative 0.2, we got a negative 0.1, 4 at the 0 value, we got a 0.1, a couple of them, I got a 0.8, 0.9, 1.3, 1.8, and 1.9. Well, if you look at that, that is the exact same image for the dot plot that we have above. They are the same. All three of them are the same. So what happened to our shape? Shape, stay the same. Our center, still at 0. Same, right? Because all we did was take our, we divided by 10, so 0 divided by 10, and it gave us 0. Because we took 0 divided by 10, that's going to equal 0. Okay? And our variability. Well, the only thing we did here was we decreased it, right? Because we divided by 10. So in other words, what's our new standard deviation? All right, we divided by 10. So our new standard deviation was 10. So if we divide it by 10, our new standard deviation is 1. Okay? So let's summarize this and think about it for a second. So if we've got this going on right here, we've got add or subtract, shapes stay the same. For the center, it went up or down by whatever value that we add or subtract here, right? So add or subtract, I'm going to say by, we'll call it a value, okay? By a value. The variability was the same from we added or subtracted, right? We had 3.8 or 38, I'm sorry, and 38 on both of them. when we subtracted, I'm sorry, from the top values. The multiply or divide shape stayed the same. The center, again, it just went by multiply or divide by, we'll call it the b value just in this case, okay? And the variability, well, we also multiplied or divide by b. Okay? So chapter 1 test scores have a mean of, well, we had a mean of 80 for our test scores, and we had a standard deviation of 10. Well, what that's referring to is for the z-scores then, we should have a 0 labeled as our mean, standard deviation of 1. So we'll talk about that for a second real quick. So on this slide, I'm going to draw normal distribution right here. Okay. And let's start out with saying our mean was at 80. I said standard deviation was 10, right? So we would have normal, our mean, and our standard deviation of 10. So with this, that's what it's referring to. This is your mean value, and this is your standard deviation, okay? So if we went 3 standard deviations above and below, our value would be 90, 100, 110. That'd be 70, 60, 50. So that is the scores, right? Okay, well, the actual thing we want to figure out now is the z-score. So the z-scores then, your mean will turn into a 0, and then you're going 1 above, 2 above, 3 above, or you're going -1, -2, or -3. That's how it's going to play out. Now, I know you don't understand 100% why I'm only going 3 above and 3 below, but we'll explain that a little bit more and what percentage of data that contains. But for right now, just understand how to calculate a z-score is by taking your x value minus your mean all divided by your standard deviation. And that gives you your z-score, right? All right, guys, hope that helped out. We'll see you next time.